Okay, so this is the chapter where you learn chemical naming and formula writing. There are 3 different sets of rules for formula writing and naming, and you're going to learn them all, and you're going to learn when to use which ones, and you are going to take a quiz, a 15-point quiz on formula and naming, formula writing and naming, and you are going to keep taking it until you get 13 out of 15 correct. And you'll take it again and again. The most I've ever had anybody have to take it is 4 times. I have 5 versions. I've never had to employ the 5th. So the way it works is we're gonna learn each system of naming. You'll learn one system. You'll take a little mini quiz on it. Then we'll learn another system. Then you'll take a little mini quiz on it. We'll learn another system. You'll take a little mini quiz. Then we'll mix them all together. And you'll have to know which system to use when. And once you've practiced those, then you will take the mixed naming and formula writing quiz. And like I said, I've never had, most people get it on the 1st or 2nd try, honestly. And I have had a few people who've taken it 3 or 4 times. And I'll explain more about that as we get closer to it. There are some incentives for getting it done and over with, other than just having it off your back. But we'll start off just talking a little bit about, ta-da! Formulas. So you already kind of know this from the last chapter, that formulas are actually different from molecular and ionic compounds, because in molecular compounds it's showing an actual number of atoms and the type of atoms. So, you know, sugar is the classic easy example, C6H12O6. It's literally 6 woo, 6 carbon, 12 hydrogen, 6 oxygen. We can look at carbon tetra chloride, one of the ones that we commonly see, CCl4. It's literally 1 carbon atom surrounded by 4 chlorine atoms. For ionic compounds, it's a little bit different because it's just a ratio. It's just a ratio of positive to negative ions. So we have to figure ratios, and it's easy if everything has a 1 charge, plus or minus, because then it's 1 to 1. And it gets more interesting as we change those charges. So in KBr, potassium bromide, we have a 1 to 1 ratio of potassium to bromine. In calcium bromide, CaBr2, we have a 1 to 2 ratio. And that's because calcium forms a +2 ion, bromine forms a -1 ion. And this is where I said, you know, you have to be really fast at knowing, oh, that's going to form a +1. That's going to form a -2. That'll be critical as we go forward with naming. So we're going to start off with the monoatomic ions. We kind of drop the O and it's monatomic. Mono meaning 1. These are ions comprised of a single atom. And you already know that if it's in the main group, it tends to want to look like a noble gas. So we can predict how many electrons they're going to lose or gain. Group 1, you might want to grab your periodic table. Go ahead and fill out a periodic table. So, group 1 tends to lose or gain? Lose. How many? 1. They lose an electron, they form +1 ions. Group 2, lose or gain? Lose. How many? 2. Group 3, of course, is in the metals. And they're weird. We don't talk about them. We're only talking about the main group right now. So, group 13 tends to lose or gain? Lose. 3. Group 14? What do you think? How many valence electrons does group 14 have? Hold up fingers. 4. You guys are fast. I like it. With 4, it's kind of a either way, because they're expending about the same amount of energy to lose or gain. Very often things in group 14 share. Carbon is a classic. Carbon tends to bond covalently. They do sometimes form ions. And often, like carbon, tungsten carbide, carbon gives up 4 electrons, and tungsten is a positive ion. So those are special cases. 15, how many valence? 5. Tend to do what? gain. Gain 3 to get that full S&P. And if you look at the periodic table, you can kind of count over. Okay, this needs to gain 1, 2, 3, and it looks like a noble gas. This needs to gain 1, 2 to look like a noble gas. So knowing that trick about adding electrons as you go is helpful. The D block is weird, and we kind of treat them separately. Should I say more about the D block? Well, let me just say, in the D block, very often, a single element can form multiple different ions. So you can have iron 2, you can have iron 3, they can have different charges. And it's because of that whole crossover SD thing, where you have, they get delocalized and they kind of wander from room to room. Okay, naming. In order to name ionic compounds, we have to know how to name ions. And it's pretty easy. So if it's a positive, it's just got the name of the element with the word ion after it. Sodium makes a sodium ion. Calcium makes a calcium ion. Magnesium makes a magnesium ion. And you do have to say ion because Na and Na1+ are different things. This is sodium, this is a sodium ion. Different things. One is balanced electrically, one is not. So that is important. I will mark it wrong if you tell me that's just sodium, because it's not. It's a sodium ion. For anions, we do a little bit of a name change. Anions, we drop the ending of the element name and we put in IDE. So a chlorine atom forms a chloride ion. A sulfur atom forms a sulfide ion. So what would that be called? Oxide ion, right. And you can kind of practice. Well, I'll tell you what, I'll give you the toughest one. So we'll get rid of oxide. We'll lead up to this. So this is a bromine atom. If it gains an electron, what would it be called? Bromide. Okay, bromide, easy. This is an iodine atom. If it gains an electron, what would it be called? Iodide. For some reason, that trips people over their feet. I don't know why. And you guys did really well with that. You were all very smooth, and you immediately said iodide. But for some reason, I think it's all the vowels. People don't want to say iodide. They're like iodide, iodinide. It's just iodide. So it sounds weird the first few times. You'll get used to it. D block, these are our metals. They are positive ions. So we get the element name plus the word ion. So we have copper ions, iron ions, silver ions. But because they have different charges, we have to specify which one we're talking about. So we always have to designate it with a Roman numeral in the middle. So copper with a 1+ is copper 1 ion. Cu2+ is what? Copper 2 ion. This is where I always say, this is the ultimate Grant's tomb kind of question. On a test, I will ask you a question like, what is the charge on an iron 3 ion? What is the charge on an iron 3 ion? 3. Positive 3, yes. I have had people get it wrong. And I think it's just they get nervous. Because it's that easy. So copper 1 has a +1 charge, copper 2 has a +2 charge, iron 3 has a +3 charge, tin 4 has a +4 charge. So those are pretty easy. When we name a compound, these are the first kind of compounds that we're going to talk about. They are binary ionic compounds. Binary means how many? 2. Binary ionic compounds only have 2 things in them. Those are really the only kinds of ionic compounds we will deal with at this level. And it's just made up of two different ions. We're going to start off talking about binary ionic compounds made of monoatomic ions. That's where we'll start. So the number of the number of positive and negative charges has to equal out so that it's electrically neutral. Did you learn the crisscross method? Is that what you guys learned? Okay, you probably did. It's been a while, I know. So if we look at magnesium bromide, Mg2+ forms a compound with a bromide ion. When we look at the two ions that are participating and we want to figure out the ratio that will work, we do this crisscross. So for magnesium 2+, bromine 1-. We literally just crisscross these, and this number without sign goes there, and this number also without sign goes there. Now, as a general rule, we don't have to write ones, so the formula for magnesium bromide is MgBr2. Sorry, geez Louise. MgBr2. Because it takes two bromide ions to balance every one magnesium ion. A couple of rules about writing the name, about writing ionic compounds. When you are writing a formula for an ionic compound, your cation always goes first. Always lead with the good news, always lead with a positive, however you want to remember that. Your cation must go first. It makes no sense if you have an anion in the first position. So when you're looking at a binary ionic compound, whatever's in the first position is your cation. Secondly, subscripts are sub. This seems obvious or stupid. Subscripts have to be written down sort of below the text. If it's up top, if it's a superscript, we're going to assume that's a charge. Subscripts are sub and signless. So there are no signs on subscripts because it's just how many of that atom there are. Okay, so let's practice a few of these. If I tell you that I have a compound that is made from calcium ions and oxygen ions, oxide ions, write down your ions. So we have calcium. What does calcium form? You need your periodic table out for this. What kind of ion? Charge. Charge. Calcium forms a 2+. What does oxygen form? What is it? 2-. So your first step in writing a formula is always to put your ions up top, and then I tend to do, well, I guess we'll pick this up tomorrow. Have a good day, folks.